Hello, everyone. And firstly, I want to say thank you, Olaf, for being there. And I hope this topic will help you a lot with working with the scrolling and so on. And first of all, let me introduce myself a bit. My name is Mikhail Zotyev. I'm software engineer, passionate about Flutter and Dart. So I have been working with this technology since 2019 and really like this. So it's a part of my official work. I'm Flutter lead at Bakersoft, and as well, I like to working around this technology as just a lot of other things like maintain the open source, which relative to the Flutter. Have my own Telegram channel about everything that's happened in this technology, everything interesting, and so on. And yeah, organizer of meetup group Flutter Voronezh, which is part of official meetup network community. So, but my personality isn't the main topic of this speech. So let's move to this topic. And it's Sliver. If you feel this picture, you have definitely worked with them already. So for people who don't, a small explanation why this meme. It's because of internal complexity of Sliver. People usually don't like to work with them because we used to have everything in Flutter really easy, really simple, high level, ready to use, just simple use and nothing more. And Slivers usually ask us to know about the internal kitchen, how it's work under the hood, and it's a bit unusual for us. Uh, Funny fact that a lot of people who start working with Sliver start know about them the similar way. Just usually we have something interesting in our scrolling system, like in design, we want to implement something wow. And we decided that it's a good idea to put one list view into another list view and just boom, red screen, nothing work. Welcome to Stack Overflow, right? And fast searching and Stack Overflow give us an answer. Just use shrink wrap through for internal list and everything will be fine. We do this, yeah, uh, exception error is disappear, but it still doesn't work like we want. It's usually lags and so on. We don't like this. We don't want this. We want wow, which wow with the lags. So we need to go back one step and find another solution. And we go searching more and we start to know that there are some slivers. How do they work? What they are? No one know. And we have two options. First of all, we can figure out how they work internally and so on. Um, and of course, we start with this. When we try to do this and understand everything that's happened there, a lot of responsibilities, a lot of properties, and so on, we say maybe it's a good idea to do it the next day, one next beautiful day, but not today. So another option, of course, we just know that there are already some ready-to-use slivers for narrow cases, but maybe we can combine them together, right? Why not? But they for special cases, and usually they don't want to work together as we want for our wow effect, right? So how to solve this? Right, a lot of hacks, and of course a pitch of hacks on top. At the end, we get something like this, and it's really best case because it's pure physics. You can easily explain why it's in balance. So it's fine. Which evil magic hold our construction? No one does know, and we don't want to return to this construction. No time in future. We just stay it like this and don't work with this more. So today we will try to fix it and explore everything about the slivers, how they work inside, and know everything that we need to work with them efficiently. So, and first of all, first question which we need is just what is the sliver and why do we need them at all? To answer this question, we will have the entry point a bit far from the main topic, but it's important. For sure, everyone here really familiar with this part. It's about how Flutter build the layout. So fastly go through this. And usually responsible for this is a render object layer, all render objects including in this. And there are 3 rules for do this. Constraints goes down, sizes goes up, and parents position their children. Everything fine. What is the constraints? And constraints usually is just for properties. It's box constraints: maximum height, maximum width, minimum height, and minimum width. And somewhere between them, our render objects choose size. And size, again, is too simple. It's just height and width. Why not? But what's happened when we face something like this is the simplest scrollable behavior, just a regular Android bar with floating. We start scrolling, a bar became smaller and smaller, then disappear. We continue scrolling, and then after some time, we decide just move to the next, to opposite direction. And this bar is appear immediately. It doesn't matter how much scrolling we already done before this, it's appear immediately. So it's not possible to implement this previous constraints and so on. What should we do in this case? And here you go, Sliver protocol. And if you think that it's completely different than we're talking about a few minutes ago, no, it's exactly the same, but constraints and the sizes more detailed. They have a lot of properties which describe every conditions and every part of possible position and so on. So the simple conclusion that Slivers, the general widget, but with a really flexible way to layouting, which make us allow to working with the scrolling. So before we go deeply to these constraints and geometry, it's okay, but we also need to manage this layouting and so on. And to answer this question, how it's managed, I would like to offer you a small interactive, maybe even a game. Let's image that Flutter doesn't exist at all, and we working on our solution for mobile development, maybe even more than mobile development, and we also need to implement the scrolling system. How we can act with this? So I will do it out loud. You can do it in your head. So first of all, I want to have one responsibility which make me allow to have impact from user, like I want to make a scroll. So I need someone who will be responsible about this. Doesn't matter which way it will happen, like maybe it's interaction with the our sensor screen, maybe it's pressing a key, or maybe force of mind we need to the future, why not? So it's a first responsibility. And second one is a place where we do this scrolling, because we need somewhere scroll objects, so we need a place. And third one is rather passive, but also we cannot scroll nothing. We need the content which will be scrolled in this. Spoiler alert, Flutter does go exactly this way, and for every this responsibilities, it has special object who responsible for this. And first of all, scrollable, it's the first responsibility. And if we check documentation of this widget, we will find something like it's a widget which can scroll. Pretty simple, really. And we do not need to know anything more, really, because it's just about the detection user gesture and understand what we need to scroll, how we need to scroll, and that's all. This widget has no clue about what is happened, what is shown, what is not shown, where is shown, nothing, just interaction with the user. And the second one is a viewport. It's exactly that container which we talk about. And it's with a Flutter, it's a working horse of all machinery of scrolling, like all management part is on this container. And as I mentioned, it's a place where we scroll, right? And why we need scroll when we have more content than we have a space for this, right? And yeah, this container is much bigger inside than outside. So some kind of black hole in the space of Flutter, because it can be really bigger inside than outside, maybe infinity bigger inside in some cases. Um, and so it's rather complicated entity, right? If we compare it with a black hole, right? We need to somehow more detailed explain what is this. And we will talk about the base cases because we have a lot of combination which we can have like horizontal scrolling, vertical scrolling, different axes and so on. So you can easily scale up to the all other combination of this property. By default, we have axis direction. It's a direction in which we can scroll in one and another way. But based on this direction, usually it's down, for example, we can highlight the two sides. It's just leading edge and the trailing edge. And when we have the one axis, probably we also have another axis. And this axis is a cross-axis direction, which tell us in which perpendicular direction we lay out our slivers. If we have two axes, they should crossing each other somewhere. This point is an anchor. Anchor is a point of crossing them, but where is it? Regarding the left or right side or cross-axis direction, it's easy. Which side is crossing first? This is a place where is anchor. But with the main axis, it's flexible. All space by main axis, it's a segment from 0 to 1. And by default, it's 0. So the default position of this anchor is the left top corner, but we can set this. For example, we can provide the information that we want anchor at 0.5 and it will be in the center of the left side. You can ask me why? Why do we need this if we don't make any calculation by our own? Like, we usually don't need this. Yeah, because of it's not only crossing point. It's a point of alignment for center sliver. And the center sliver is rather important one because regarding this center sliver, all other sliver are calculated and so on. And also ordering relative to this center sliver because all slivers after him growing in the forward direction and all previous him in opposite direction, and which is the center sliver. By default, if we do not set something special, it's the first one. So you can just see this really default situation. And we can set it up by providing the special key to viewport and say, something with this key will be a center sliver. And when we put this key into the sliver, it will make the sliver center. For why we need this? We can easily set up every started condition for our scrolling part. Like we can just put a lot of slivers already over top, for example, or position our slivers in the special point of our screen. Another important thing about the viewport is the caching. So we want to have our scrolling smoothly, right? Because user don't want to have lags because of scrolling. So caching areas will help us to avoid this. Because of this caching area, we can pre-create a lot of objects, and before we show them in visible part of viewport, they already prepare it here or there. And by default, they 250 size, but you can set it up. And of course, it's not only creating. When our sliver left the visible part, we can not destroy it immediately because we have this caching area and make our scrolling smoothly. In general, all sides of our viewport is a visible part and two cache area. Let's put it together. We have scrollable and the viewport. How they work together. Again, it's one of the default case, but you can see there are one. And both of them have a different numbers on the something that represent the slivers. And why they different, it's about the growing direction. If our next sliver appear in the same direction as axis direction, we mean that it's growing direction forward. If it's opposite, that reverse. And why we need this? Because of scrollable provide us information about user. User wants to scroll or not. And it can be different values. First of all, if user do nothing, it's idle. If user put his finger in the screen, but again, without movement or something else, it's still idle. But as soon user start move his finger and everything move with this finger, we get this information about scroll direction, and which one depends on which of sliver is appear. If our movement make appear the next one, it means that it's forward direction. If previous one, it's reverse direction. And of course, opposite, change the tables. So the last one, responsibility. We talked already about this, and I mentioned that it's rather passive, not for Flutter. For Flutter is a bit active, but on the background side, on the hood side. So as we already know, we have the constraints and the sizes. And the constraints, it's a sliver constraints. I prepared a small application which will help you go through this journey and check the value of constraints. There are few tabs, one for setup, one for checking the values, and one represent the scrollable area. Of course, better to hold if you use a phone, so hold the landscape mode. Let's go through them. And we already talked a lot about the constraints, but we didn't mention it still. For calculation of the sizes, we have in constraint every information about the viewport, like directions and so on, and even user interaction, user scroll direction. But not only this, we also have additional property. First of them is scroll offset. It's described the offset of the earliest visible part of the sliver, relative visible part of the viewport. And sounds easy, but here are a lot of tricky things. First of all, we talk about the leading edge of the sliver and the leading edge of the viewport. It's really important. Before we crossing this leading edge, scroll offset is 0. It can be confusing because by default, the anchor and the leading edge, they just at the same level. But it's exactly about the leading edge, because if we have case like this, when our sliver cross the anchor but still doesn't cross the leading edge, it's still 0. And as soon as crossing the leading edge, we have this size, so scroll offset will be represented by this. And again, it's not about the physical size. We work with the logical size. We work with the leading edge, because of if we have the scrolling axis up, leading edge will change, and leading edge will be for sliver bottom, and here also bottom. It will be scroll offset in this case. Another one is proceeding scroll extent. It's a scroll distance that can be consumed by all render slivers that came before render sliver. Again, something really simple, but again, tricky case. Often slivers, they are really lazy. They don't want to create everything when they don't need it. So if some sliver go after this lazy sliver, before this lazy sliver create everything, no one does know which side it will be, right? And in this case, no one know about this property. It will be infinity all time before everything created and calculated, and then we can know about this. Next property is remaining pane extent. It's a number of pixels or content which Sliver should consider providing for painting. And providing more pixels, it's not efficient. So we have the painting area, like visible part, and since our sliver can go through this distance, it can take more space to paint. But it's not mean that it should take all this place. It can, but it can like use exactly this and nothing more. And we talk about the painting, so as soon we crossing the leading edge, again we have the all visible part of viewport and this remaining pane extent that we have. Yeah, before we go to the visible part, we don't have a place to paint at all, so it's 0. Remaining cache extent is exactly the same, but with a different restriction. If previous time we talk about the painting, here we're talking about the layouting. So for us, also important the cache area part. So yeah, before we crossing the end of cache, it's again just growing, and the maximum is remaining cache extent. All visible part and the cache area part. Before we go to viewport, of course, it's 0. And one more property about the cache, it's cache origin, where the cache area starts relative to scroll offset. We know that we have this caching area, and for us, not important that we have this cache area for this property. So before we go again to the leading cache area, it's still 0. As soon we go to this cache area, it start be and grow like the value of scroll offset, but with a negative sign. And the maximum value, of course, is cache extent. After this, doesn't matter how we continue scroll far, it will be the same cache extent in this case again. And even if we have the big one, the part of them still invisible part, we just have this like cache extent. And the last property that we have in constraints is overlap. It's size between the first painted pixel of the sliver and first not covered by previous pixel. The better to check this on the example because it's relative to the floating effects. Just image that it's some a bar or floating widget, doesn't matter, and our widget. Before they cross each other, it's just 0. If a bar completely disappear, it's again 0, nothing overlap. But in case we have some overpainted part, we will know that this part is overpainted. We can react on this somehow on the layouting, and this is also case. And even if we have something like this, it's usual for Cupertino behavior for bouncing scroll when you can just move out from the normal position, and when you release this, it will go to this place. It will be negative. So based on this, we need to decide which size our render has. And for this, we have this sliver geometry. It's exactly description about the size. And as you can see, here's a lot of properties. Probably we don't have a lot of time for go through all of them. So you can check, of course, every one of them in the Flutter documentation or in my article. They it's a bit more detailed with these details, of course, too. So, but I would like to offer you a bit different experiment with this. So when I was thinking about how to show this, I decided that we can make something interesting with scrolling. And I remember this person from Silicon Valley, Russ Hanneman. Do you remember his special attitude to car doors? So yeah, I decided, we're Flutter developers, why our widgets left screen so boring like this, not like this, or like this. So let's make something that Russ Hanneman would like. So I already did this, and in form in the package, you can use it if you want. It's open source, available on pubdev. But we will go through the implementation and check how it can be done. So first of all, we have the widget, and this widget is contains something inside. So we need a child. So based on this, we will extend the single child render object widget. And in this implementation, we need to create a special render object. Let's call it spinner render sliver. What is this? It just extends of render sliver and with a special mixin which will help us a bit with the calculation. So because of our child is a regular widget, it's has this parameter render box. So how we can implement this? First of all, we need to decide where we exactly is. And when we decide where we is, I mean the render sliver, we can decide based on this, should we rotate or we shouldn't? And if we should, we need to decide in which angle we should rotate. So to hold all this decision, we need a few properties. First of all, paint transform, matrix 4, which showed us our decision about the rotation. Do we have this or not? And which exactly rotation? And the transform layer in which we will apply this rotation. So as soon as it can be changed in every movement, we need to manage this in the perform layout method. And I said already that it can change every time, so we will start from the resetting our previous decision. After this, we need to understand which size we have, because we don't have our own size. We have only child size. So we simply delegate to the child this decision and say, okay, here's our constraint, but it's a simple way as a box constraint, and we will use your size in our purpose. So that's it. We know the maximum size which we can use because it's the size of our child. And then we need to small calculation about the painting part and the offset cache part. We don't need to do it our own. We can use the ready method that already exists. So now we have both of them, and we can decide should we rotate or not. So when we need to rotate, when we crossing the leading edge, after this we need to spin, depends on how much we move out. So scroll offset will help us. As soon as it became bigger than 0 and we have at least something to paint, we will do this. So the angle will calculate it like relation between the painted part and the maximum part of our size. Based on this, we calculate the angle. But we cannot apply this directly because rotation applied to the center, but we won't rotate on the left bottom corner. So we need the translation, which will help us. So first of all, we started from the base matrix and then make a translation, rotation, and move back. Okay, and the next step, we can decide about our size and provide this geometry. We already know the maximum size. We can know that we need to scroll exactly this size to scroll out. We know this part which is painted and everything that we need. So we have a child, and we need to provide them information about our constraints. So this constraint will help to adjust axis and so on. Based on this, it's, to be honest, it's just simple implementation which you can find everywhere. A lot of places like sliver to box adapter, completely the same, just will not stay a long time on this. But we already make decision about the rotation and so on, but we still need to paint. And if we have child, if we have a geometry visible part, so we need to apply our transformation, so rotation, or if we don't have rotation, just default one, and paint child. Everything fine. Last step is applying transform, because we have our own decision about the rotation, but somehow we can also have something outside, and we need to combine this together, and a simple multiplication of our two matrices and providing this to the child data. As a result, we have this. So pretty simple and easy to implement this on this level without all knowledge about the position and everything, without additional calculation on the widget layer when it's not relevant already, maybe. So if you like this example and so on, you can find in my GitHub every this material, links to this. So also all contacts to reach me, ask something or connect, you are welcome. And last point, if you have a question, I'm ready to answer them. Thank you for your attention.